Hello everyone. Myself Dr. Ranjana Gogoi, Associate Professor in Statistics working at Gorgaon College. Today I am going to deliver a lecture on measurement of the component of trend in the analysis of time series. This lecture is based on the syllabus of BSc non-CBCS 6 semester statistics major paper applied statistics which is taught in the colleges under Dibrugarh University. The main problems in the analysis of time series are to identify the forces or components at work, the net effect of whose interaction is exhibited by the movement of a time series, and to isolate, study, analyze, and measure them independently, that is, by holding other things constant. Now, mathematical models for time series. There are two models commonly used for decomposition of a time series into its components. The first one is the decomposition by additive hypothesis or additive model. According to the additive model, a time series can be expressed as yt is equal to tt plus st plus ct plus rt, where yt is the time series value at time t. In the additive model, tt represents the trend value, st, ct, and rt represent the seasonal, cyclical, and random fluctuations at time t. The term st, that is the seasonal component, will not appear in the series of annual data. The additive model implies that the seasonal forces in different years, cyclical forces in different cycles, and irregular forces in different long period operate with equal absolute effect irrespective of the trend value. As such, CT and ST will have positive or negative values according as above normal or below normal phase of the cycle and year for the seasonal fluctuation, and total positive and negative values for any cycle and any year will be 0. RT has also positive and negative values, and in the long term the total will be 0. The additive model assumes that all the four components of the time series operate independently of each other so that none of this has any effect on the remaining three. Next one is the decomposition by multiplicative hypothesis or multiplicative model. If we assume that the various components in a time series operate proportionately to the general level of the series, the traditional or classical multiplicative model is appropriate. According to the multiplicative model, yt is equal to tt into st into ct into rt, where st, ct, and rt, instead of assuming positive and negative values, are indices fluctuating above or below unity, and the geometric means of st in a year, ct in a cycle, and rt in a long-term period are unity. In a time series with both positive and negative values, the multiplicative model cannot be applied unless the time series is translated by adding a suitable positive value. The multiplicative decomposition of the time series is same as the additive decomposition of logarithmic values of the original time series. That is, log of yt is equal to log of tt plus log of st plus log of ct plus log of rt. So most of the series relating to economic data conform to multiplicative model. Now, uses of time series, it enables us to study the past behavior of the phenomena under consideration, that is, to determine the type and nature of the variation of the data. The study of the various components is of paramount importance to a businessman in the planning of future operations and in the formulation of executive and policy decisions. It helps to compare the actual current performance of activities with the expected ones and analyzes the causes of such variations. It enables us to predict or estimate or forecast the behavior of the phenomenon in future, which is essential for business planning. Time series helps us to compare the changes in the values of different phenomena at different times or places. Now, the measurement of the component of trend in a time series. Trend can be measured by the methods of graphic method or freehand curve fitting, method of semi-averages, method of curve fitting by the principle of least squares, and method of moving average. Graphic method or freehand curve fitting. A freehand smooth curve obtained on plotting the values of yt against t enables us to form an idea about the general trend of the series. Smoothing of the curve eliminates other components, namely regular and irregular components. This method does not involve any complex mathematical techniques and can be used to describe all types of trends, linear and nonlinear. Simplicity and flexibility are strong points of this method. But its limitations are, it is a subjective method. That is, the bias of the person handling the data plays an important role, and hence different trend curves will be obtained by different persons using the same set of data. So it does not enable us to measure trend. The next method is method of semi-average. In this method, the whole data is divided into two parts with respect to time. Next, the arithmetic mean for each part is computed and are plotted these two averages against the mean values of the respective time periods covered by each part. The straight line obtained on joining these 2 points is the required trend line, and it may be extended both ways to estimate intermediate or future values. The merits and limitations of the method of semi-average are, as compared with graphic method, the obvious advantage of this method is the objectivity, in the sense that everyone who applies it would get the same result. Also, we can estimate the trend values. It is readily comprehensible as compared to the method of least squares or the method of moving average. The drawbacks are, this method assumes linear relationship between the plotted points which may not exist. The limitation of arithmetic mean as an average also stand in its way. The next method is the method of curve fitting by the principle of least squares. It is the most popular and widely used method of fitting mathematical functions to a given set of data. Method of least squares provides accurate results if sufficiently good form of the function is used to fit by scrutiny of the graphical plot of the values over time or by theoretical understanding of the variable under consideration. Various types of curves that may be used to describe the given data in practice are a straight line, yt equal to a plus bt of the form. Here yt is the value of the variable corresponding to time t. The second degree parabola, yt is equal to a plus bt plus ct square. Then kth degree polynomial, this is nothing but yt is equal to a naught plus a1t plus a2t square plus dot 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 ak t to the power k. Then exponential curve, yt is equal to a b to the power t, and in logarithmic form it is log of yt is equal to log of a plus t log of b, or capital A plus bt, where capital A is log a and log b is capital B. Then second degree curve fitted to logarithm, this is yt is equal to a b to the power t c to the power t square. And if you take the logarithm of both sides, then it will be log of yt equal to log of a plus t log of b plus t square log of c, and which can be, we can write like this, a plus bt plus ct square. The growth curves are yt equal to a plus bc to the power t. It is the modified exponential curve. Then Gompertz curve, yt equal to a b to the power c to the power t. And in logarithmic form, it is equal to log of yt equal to log of a plus c to the power t log of b, which is equal to a plus b c to the power t. Then logistic curve is yt is equal to k by 1 plus exponential a plus bt. Following points to be noted while type of trend to be fitted for given set of data is selected. If the time series data is found to be increasing or decreasing by equal absolute amounts, then straight line trend is used. And when the series is increasing or decreasing by a constant percentage, then logarithmic straight line or exponential curve is used. If the data plotted on a semi-logarithmic scale is not a straight line graph but shows a curvature, then second degree curve is used. It is known that for a polynomial yt of nth degree in T, then del r yt is constant when r is equal to n. That means the nth difference of nth degree polynomial is always a constant, and otherwise it is 0 when r is greater than n. Here delta is the difference operator, which is defined as delta yt is equal to y t plus h minus yt. Here h is the interval of differencing and delta ryt is the rth difference of yt. So if delta yt equal to a constant, then you use a straight line. If delta square yt is constant, then use a second degree parabolic trend. If delta log of yt is a constant, then use exponential trend curve. And if delta square log of yt is a constant, use second degree curve fitted to logarithm. The modified exponential, Gompertz and logistic curves can be approximated by the constancy of the ratios of this type. Respectively, the first one is for modified exponential curve, second one is Gompertz curve, and third one is for logistic curves for all possible values of t. Now, we are going to fit a straight line by least square method. Let the straight line trend between the given time series values yt and the time t be given by the equation yt equal to a plus bt. So, principle of least squares consists in minimizing the sum of the squares of the deviations between the given values of yt and their estimates given by this equation yt equal to a plus bt. So we have to find a and b such that for given values of yt corresponding to n different values of t, this e equal to, this is the error estimate, summation I in bracket yt minus a minus bt to the power whole square is minimum. Thus we have two normal equations by making del E del A equal to 0, that is the partial derivative of E with respect to A equal to 0 and partial derivative of E with respect to B is equal to 0, from which we get two normal equations of this type. And here there are two unknowns A and B and we have two normal equations. So by solving these two equations we get the value of A and B, and thus we get the desired trend line. Then fitting of second degree parabolic trend. The second degree parabolic trend is defined as yt is equal to a plus bt plus ct square. So proceeding similarly as in the case of straight line, the normal equations for estimating a, b and c are given by these three normal equations. Here again, three unknown constant a, b and c are there and we have three normal equations. So by solving these three normal equations, we get the values of a, b and c. Here the summations being taken over the number of values of the time series, and after solving these three equations for a, b and c we get the desired trend line. So in a similar way we can fit the trend line by using exponential curve and second degree curve fitted to logarithms where necessary. The merits of least square method. The method of least squares is the most popular and widely used method of fitting mathematical functions to a given set of observations. Due to its mathematical and analytic character, this method completely eliminates the personal bias of the investigator. This method enables us to compute the trend values for all the given time periods in the series. The trend equation can be used to estimate the values of the variable for any period t in future. The curve fitting by the least squares method is the only technique to obtain the rate of growth if the linear trend is fitted. The demerits are in the addition of even a single new observation requires all calculations to be done afresh. The method is quite tedious and time-consuming as compared with the other methods. It is difficult for non-mathematical persons to understand. Trend completely ignores to measure the cyclical, seasonal, and random fluctuations. The most serious limitation of this method is to determination of the type of the trend curve to be fitted. So dear students, I conclude today's lecture here. Thank you.